So, string tension is 17 newtons. What is the block speed after moving 0.9 meters? So, it's kind of a two-part problem, right?
Mm-hmm.
You've got this block sitting, it's got a string on it, 17 newtons.
Mm-hmm.
And how much does the block weigh?
1.5 kilograms.
So this is 1.5 times 9.8, it's the force of gravity on it.
Okay.
So the normal force will be the same.
Mm-hmm.
So what will the friction force be?
So let's see, 1.5 times 9.8 is 14.7. And that's just equal to 0 on the y.
Right?
Let's see, and the coefficient of static friction is 0.8.
Okay.
The kinetic friction is 0.6. That's when they're dry.
Right. So which one did you want to use of those?
Well, let's see, I would want to use kinetic because it's moving, right?
Right. So what would your friction force be?
0.6.
That's the coefficient of friction.
Okay,
So that's determining how sticky the surface is.
okay.
Then what else determines how much friction force there is?
I can't remember how to figure this one out.
So it's like with friction, you try to remember the coefficient tells you how sticky the surface is, and then the normal force tells you how hard they're being pushed together.
Okay,
So the harder two things are pushed together, the greater friction there is,
okay, so it's 14.7 is the normal force.
right? So that's how hard they're pushed together, and then the coefficient of friction is 0.6. You just multiply those two
Okay,
and give you your friction
Dang.
force.
I missed that on the test.
Oh, really?
Yeah, I actually did really bad on the test. Well, I don't know yet, but I think I did bad. I guessed a lot. But, so 14.7 times 0.6. Okay, so I got 8.82.
Okay?
And that's your kinetic friction.
Yep.
Okay.
So what's your sum of forces in the x direction?
So we got 18.2, negative 18.2.
Just 8.2, yeah.
Oh, excuse me, 8.2, 8.2, excuse me. And 17.
Okay?
Okay, so you just take 17 minus, let's see, 17 minus 8.82. It's 8.18.
Okay. And what will that be equal to? Do you remember when you sum your forces?
That's your net force?
Yep. So that's net force equals mass times acceleration, right?
Okay, yeah. Okay, so we're looking for the tension on the string now, so the mass is,
Well, we had the tension. What's the question asked for? The speed, right? What is the block speed after moving 0.9 meters?
yeah,
Okay, so the mass is 1.5. You can solve for the acceleration, right?
okay. So, let's see, it's 1.5, so 8.8, or 1 divided by 1.5, 5.45
Okay.
meters per second.
And then you want to find its final velocity, right?
What is the block speed after moving 0.9 meters?
So basically you have this idea, right? It went 0.9 meters, with acceleration of 5.45.
Meters per second squared.
You're trying to find this.
Yeah.
What do you know about the beginning?
It's 0.
Yeah, so the velocity was 0. Or oops. plus initial equals 0. So then you can use this equation. V final squared equals V initial squared plus 2A change in x.
Okay. So we're trying to find V final. So let's see, 0 plus 2 times the acceleration 5.45. The change in x, that's 0.9 meters.
Okay. So the square root of whatever this is?
Let's see, square root of 2 times 5.45 times 0.9. 3.13
Okay.
meters per second. Alright, so I think what was holding me back on that one was how to figure out the
Friction.
friction. I did that wrong on the test. So.
Yeah, so friction is always going to be, whatever kind it is, it'll be your normal force times your coefficient of friction. So kinetic, static, whatever it is.
I'll put that on my card real quick.